towers with Towers Arms, week 6 of FTT 122. This week we're going to talk about a few things. We have trajectory and sights, gyroscopic drift, drag, Magnus effect, Coriolis effect, vertical angles, and transonic ballistic performance. We're going to go ahead and start with the trajectory and sights. I drew a little diagram on the whiteboard. So as you can see, we'll pretend that this is the sights and a scope or whatever, and then this is the barrel. As the bullet travels, it has a slight arc to it. And you have 2 points of zero with your sights. You're going to have the first intersection, then you're going to have the second intersection for your points of zero. So as you can tell, you're actually looking at where the bullet is falling if you were to do a 2-pointed zero with like a rifle. So as you can tell on my crude drawing of a pistol here, you can see that we have our 2 points of sight. As it goes out, there's only going to be one intersection, since pistols usually have a lower range, shorter range. So as you can see, the trajectory is the red where they intersect. This will be our point of zero. And next we have gyroscopic drift. The best way I can explain this is as the bullet is rotating due to the rifling, it's spinning and it creates a gyroscopic effect, which actually stabilizes the bullet, but it also has a sideways deflection as it's traveling. So it's going to end up moving slightly significant at 100 yards. So that is gyroscopic drift. As it's rotating, it's creating a pull in a single direction, whether the rifling is in the left-handed or right-handed orientation. So for bullet drag, the best way I could show it is by the blue representing the wind or the air that's outside of the barrel. As the bullet's in mid-flight, it's going to have resistance from the air pushing, from the oxygen and everything pushing onto the bullet. And it's creating drag as it's coming across the face of the bullet, which is slowing down the bullet. Next, we have the Magnus effect. So this is looking from the rear of the bullet. As you can tell, it's slightly off axis. So if it was creating enough drag on this side, the wind is actually going to force it right, which is the Magnus effect. So we have the Magnus effect, where is the rear of the bullet and this is the center of the bullet. So as you can tell, it's slightly off. So if you have a bullet that might not be fully centered, you can have air resistance on one side, which is going to cause a deviation where it's being forced in one direction. So we're going to move on to the Coriolis effect. As the earth is rotating, if you were to fire in either a north-south direction, the Earth's rotation will actually come into play as the bullet gets further away from its target. The Earth is actually moved since being fired. The bullet will reach its impact at a different location because the Earth has actually rotated. If you were to fire north to south, the Earth is rotating east to west, which will cause it to go to the right, and vice versa. If you're firing from the south, it's going to cause it to go to the left. So that is the Coriolis effect. It's very similar with the Eotvos. I believe that's how it's pronounced. Since the Earth is actually rotating, and if you were to fire in either east-west orientation, your target is actually going to be lower or higher based on which direction you're firing at. So because of the Earth rotation, your target is actually going to be higher or lower depending on east or west. So with vertical angles, it's slightly different than the Eotos or the Coriolis effect. When you're firing in a downward angle, you're going to have a flatter trajectory. It's going to have less of a curve because it's already going with gravity. So if you're to fire at a downward angle at the target, it's going to be a flatter trajectory than if you were to fire at an upward target. You're going to have more of a curve in the trajectory. So transonic ballistic performance. This is our projectile, and as it goes from a supersonic to a subsonic speed and velocity, it's actually going to create more resistance, and it could actually have imbalance effects cause the bullet to destabilize as it goes from supersonic to subsonic, which can create different trajectories. Thank you everybody for watching. That was week 6 of FTT 122. This is Eric Towers for Towers Arms.